Lesson 4.4, standard deviation. Our objective for this lesson is to be able to calculate the standard deviation of a data set. Let's start by defining standard deviation. Standard deviation is a measure of how far data values are spread around the mean of a data set. So with standard deviation, we're trying to describe the variation in a data set using a single number, as opposed to the 5-number summary that uses obviously 5 numbers. Also notice that the standard deviation uses mean as the center of the data set, whereas the 5-number summary uses the median. In order to calculate the standard deviation, we need to calculate the deviations from the mean. So the standard deviation is essentially the typical distance that each of the data values is from the mean. So the first step is to calculate the difference between each of the data values and the mean. And that's called the deviation from the mean for that data value. So the deviation from the mean is equal to the data value minus the mean. Once we've got those deviations from the mean, we're ready to calculate the standard deviation using this formula. Standard deviation is equal to the square root of the sum of the deviations from the mean squared divided by the total number of data values minus 1. So first we're going to calculate all the deviations from the mean, and we're going to square each of those deviations from the mean. Then add up all of the squares of the deviations. Once we have that number, we're going to divide by the total number of data values minus 1. And then we'll take that number and take the square root of it. And that will give us our standard deviation. Now, that standard deviation calculation is fairly complex. And so we have a quick rule of thumb just to kind of get an idea of what the standard deviation will be. And the rule of thumb is this, the range rule of thumb is to estimate the standard deviation by taking the range and dividing by 4. And note that this doesn't work well when there are outliers. But if there aren't large outliers, we can just take the range and divide by 4, and that's going to give us a rough estimate of what the standard deviation is going to be. For our example, we're given 2 sets of data, which we're told represent the wait times for customers standing in line at 2 different banks. And we're asked to calculate the mean and standard deviation for each data set. So here we have the first data set, and let's start by calculating the mean of this data set. So if we add up all of these numbers, 1, 2, 3, 10, 18, 20, 34, 35, 36, 37, 42, then 8, 18, 30, 44, 59, 79. So 79.2 is the total wait time. And then we divide this by, there are 11 different times here. So if we divide this by 11, that's going to be 7.2 is our mean. So let's stick that over here. We'll put mean 7.2. Now, to calculate the standard deviation, we're going to need to first find all of the deviations from the mean. So we're going to subtract the mean from each of these data values. So we'll just subtract 7.2 from each of these. Oops. 7.2 minus 7.2. Okay, now so then that will give us the deviations from the mean for each of the data values. So 4.1 minus 7.2 is negative 3.1. 5.2 minus 7.2 is negative 2. And then we have negative 1.6, negative 1, negative 0.5, 0, and then 0.5, 0.5, this is going to be, sorry, not negative, this is going to be positive 1.3, and then 2.1 and 3.8. So those are all the deviations from the mean. Now what we need to do is square each of those deviations from the mean. So negative 3, and notice that when we square these negative numbers, they're going to become positive. So that's one of the reasons that we square these, is so that all the numbers will be positive. Another reason is that squaring them really accentuates the differences. So it's really going to emphasize these outliers out there. So 3.1 squared is 9.61. 2 squared is 4. 1.6 squared is 2.56. Then this is going to be 1, 0.25, 0, 0.25, 0.25. 1.3 squared is 1.69. 2.1 squared is 4.41. And 3.8 squared is 14.44. All right, now let's add up all of the squares of the deviations from the mean. And I've added those up, and these come out to 38.46. Yeah. Now we're going to divide this number by the total number of values minus 1. So the total number of values, just which we used for the mean, is 11. Now we're going to divide by that minus 1. So we're going to divide by 10. So if we divide this by 10, that's going to be 3.846. Now, finally, we take the square root of 3.846, and we get that the standard deviation is going to be approximately 1.96. 1.96 is the approximate square root of 3.846. Now I have the wait times for the second bank up here in red, and let's calculate the mean and the standard deviation for this data set. So 6 plus, let's see, that's going to be 20, 30, 35, 50, 62. So 0.2, and then 6 times 5 is 30, plus 49 is going to be 79. And if we divide that by 11, we get 7.2, just as we did with the earlier data set. So the mean here is going to be 7.2. So the average wait time for both of these banks is the same. Now let's take the mean and subtract that from each of the data values to find the deviations from the mean. So subtract 7.2 from 6.6, we get negative 0.6, and negative 0.5, negative 0.5, negative 0.3, negative 0.1, 0, 1, or 0.1, sorry, 0.2, 0.5, 0.6, and 0.6. So those are the deviations from the mean for each of these data values. Now let's square each of those deviations. So this is going to be 0.36, 0.25, 0.25, 0.09, 0.01, 0, 0.01, 0.04, 0.25, 0.36, and 0.36. And if we add those up, we have see, 15, 25, 26, 27, 36, 48, and then 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So 1.98. And now, just as we did before, we're going to divide by one less than the total number of data values. So we're going to divide by 10, and that's going to give us 0.198. And we take the square root of that, which is going to be approximately 0.44. So we can see that the wait times for both of these banks were the average wait time was the same, but the deviation in this second bank was much smaller. In other words, most of the customers can count on a particular wait time, rather than sometimes they go in and they get out really quickly, and sometimes they wait a lot longer. So that's how to calculate mean and standard deviation for a data set.